Okay, so 3.1 inch from the top. And that the IZZ is equal to 197.7 inches to power 4. Okay, so this I mean, you have to find this, but I don't want to waste time. I rather explain the concept to you, how to analyze a problem like this. So if this is our X, this is our Y, and over here, this is the Z. Okay. So again, if you look at a problem like this, so what we are given is that we are given Q, or resistance force, right, per new. Okay, so this is our F, and it's at 50 pounds, right? And then we are given the spacing S is equal to 2 inches, right? So what we are given now is we can calculate Q is equal to F divided by S, and this is 50 divided by 2, and is 25 pound per inch. And then we can relate this to Vy over IZZ QZ, right? So rule number 1, Vy is a constant, IZZ. The problem is always the QZ, right? What area do you analyze? Okay, so I'm going to sketch the cross-section view. Okay, I'm going to sketch it out. Okay, and we're going to apply rule number 5. Okay, we're going to apply rule number 5. So this is 1. So I'm doing the cross-section view now. Okay, so 2, 4, 6, 8, 10, 12. Okay, and then we go for 6. Then we have 6, 2, 4, 6. Okay, and then we have 5, 2, 4, 5. Okay, and then we have it fastened by 1 inch. Hey. Right? Okay. And then the centroid is 3.1 from the top. Okay, so this is our centroid. And transformation Y, Z, rotation about X. Okay, and this is our Vy. All right, so if we were to construct our shear flow, right? So rule number 5 is what? Is controlled by the web, right? So you construct the shear flow on the web first, right? The web controls it, right? These are the web, right? So it goes down this way. right? And then we have our fastener. If you look at our fastener, right, we have a fastener here. We have another fastener here. We have a fastener here. We have another fastener there. Right? So those are our fastener, right? So what you see down here is how the fluid works. So that controls the the shear flow. Okay. Then I have to construct further, right? It's like fluid flow, right? So if that's the case, this one it has to go in. Right. This one it has to do this. Right? Right, it will transmit, then at the other end it has to do this. That's how fluid will flow. Okay. So so that's why it's so important. Rule number 5 is the web controls the shear flow. Once you construct the shear flow on the web, the rest just come in. That's what I just did. Okay. So from here, where the failure will occur is the failure I'm going to do in red. Okay, the failure will occur here, 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 and here. Right. So again, we have to determine where the failure. So there are two different areas of failure. Okay, so over here, because the structure is not asymmetry about the centroid. Okay, we have, so the top joint and the bottom joint, they're not symmetrical, is it? Unlike the previous example, right? The previous example, the top joint and the bottom joint, right? If I draw this, the failure will be here, 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 or here is symmetrical. Okay. For this problem over here, it's not symmetrical. So you have to analyze failure at the top flange and failure at the bottom flange. Okay. So we're going to do, so there are two possibility. Okay. So we're going to look at failure. Okay. Failure at the top flange. Okay. As I mentioned, it is the first moment of area that is very disturbing. Yes or no? Okay, very very disturbing. Okay, so now, so if so we are going to find what is our QZ first. Okay, so QZ is to consider. All right, so we apply our rules. The analysis starts from where? Start from Y max. Right, so this is our Y max. Right, so this is your analysis direction. Right, so when it hits the joints or top flange joint, right, the shear flow that we have to consider is this area. Okay, so from here you calculate QZ is equal to A Y bar. Right, so the area, the width is 12. Okay, the depth is 1, and the Y bar is 3.1 minus by 1 divided by 2. Okay, so 3.1 is the centroid. So 3.1 minus half times by 12 times 1, so it's equal to 31.2 inches cube. Right, so we want to find our Q. Right, we want to find our Q is equal to VQ over I. right? So we found our Q, right, is 25, right? So this is 25. Now, 25 is only for, this one is only per nail. Yes. But over here, it has been split to left and right, yes or no, right? Over here, the nails that are holding it, you have the left nail and you have the what? Right, right? So you have to multiply by 2. Then you have your V, which is what you want to find out. Right, so sorry, so this is Vy over Izz Qz. So your Izz now is 197.7 and your Qz is equal to 31.2. So your Vy is equal to 25 times 2 times 197.7 divided by 31.2 is equal to 316.8 pound force, or you can round it up to 317 pounds. Okay. Now that is the failure at the top flange. Okay. Then the confusing part is when we look at the bottom flange. Okay, we look at the bottom flange. There's a confusing part. So if we look at failure at the bottom flange. Now the thing is, you will look like Eugene. What area are we looking at? Okay. A piece of advice: the area is not dependent on the arrow direction. Okay. Watch. So now we want to find at the bottom, right? So this is the bottom flange joints, right? So the rule says what? The analysis, this is the analysis direction, right? It will start from what? Y max. If there's an analysis direction, right? This bottom flange wood will distribute the load, right? The bottom flange will distribute the load. Okay, I better write properly. Will distribute the load. And then the nail will what? Transmit, yes or no? Right? So it need to distribute first, then it can transmit. Okay, so in that case, right, because the analysis starts from y max go into y equal to 0, the only member that's covered at after this distance, right, is your what? Is your flange. Okay, so the Q down here, okay, is the what? Bottom flange. Some of you will ask me, Eugene, why don't we consider the web? Right? Why don't? Because for the shear flow to go or to be transmitted from the flange, you have to go to the what? The fastener. Okay, only for that reason. Remember, these 4 parts are made from separate parts. Okay, so from here, your QZ. I think you guys are probably too tired to ask any question now, right? I hope you guys will see this video, especially the last half an hour. I think you guys are switched off already. That's my feeling. I can be wrong. So the width is equal to 6. The depth is 1, and the top flange is 3.1. So the entire height is 7 minus 3.1 minus 1 divided by 2. Okay. So 7 minus 3.1 minus 0.5 times 6 times 1 is equal to 20.4 inches